Hello everyone, we are on to our final chapter of our Big Ideas textbook, which is over 3D figures and shapes. We will be discussing surface area and volume, as well as lateral area as well. So most of the year we've talked about 2D shapes. Now we're going to talk about 3D shapes. And 12.1 discusses three-dimensional figures. So our first set is always vocabulary, and our first vocabulary term is a polyhedron. And so think poly as like polygon. It does mean many. Hedron is going to pertain to faces, edges, vertices, etc. So a polyhedron is a solid bounded by polygons. So think of this as a 3D shape that has many polygons, such as a triangle, square, rectangle, etc. And so there's many of those, and they're all connected. And that's what's called a polyhedron. And polyhedrons are also non-circular. So keep that in mind, non-circular. So our next vocabulary term is a face, and that is a flat polygon. And it's also a portion of a plane. So when you have a 3D figure, that face where you can sit it flat, that's the polygon. That is considered a face. The edge is a segment of a line intersecting two faces. So if I had two faces, that connection that they have is called an edge, and it's usually very sharp. And our next vocabulary term is a vertex, and that is a point where three or more faces three or more edges, pardon the whiteout. This is where three or more edges, So three or more edges meet. So a vertex is a point where three or more edges meet. Then we have what's called a cross section. So this is, for example, I were to have a block of cheese, and I took a knife and I cut it. Well, the cross section is kind of that overlining figure that's within the knife and the cheese being cut. So the cross section is an intersection of the plane and the solid. So we'll see a couple of examples on what a cross section is. The solid of evolution is a 3D figure formed by rotating a 2D shape around an axis. So this is where if I had this pen, for example, and I took a sticky note. And I start off with a 2D figure. So if I were to take this sticky note and I were to extend it all the way around, I kind of create this cylinder, so to speak, if it was a more solid sticky note, and then the pen would be called the axis of revolution. So that's what the solid of revolution would look like. And so the axis of revolution, like my pen, is a line around which the shape is rotated. So those are our definitions for this particular section in Chapter 12. So we're going to flip to the next page and continue on with some core concepts and extra examples. Our next page gives us the core concepts of types of solids. So of course we have a polyhedra, and this includes a prism and a pyramid. Well, we have not polyhedra, or the cylinder, cone, and sphere. So if you look closely, they have some similarities and differences. Notice that the polyhedra have a whole bunch of polygons. They all have sharp edges, as well as the not polyhedra, they're very circular. So again, we have a circle, there's a circle, and a sphere is in a 3D circle. So if it's any by means have a circle involved, it's not a polyhedra. Whereas anything flat with many polygons involved, then that is considered a polyhedra. So now we're on to our extra practices. So exercises 1 and 2, tell whether the solid is a polyhedron. If it is, name the polyhedron. So we'll look at number 1. So remember, polyhedrons have a lot of faces, a lot of edges, and a lot of vertices. And so this one is considered, yes, a polyhedron. And then we have to name it. And so when you name it, you name it based on how many faces or how many vertices that you have. And so if we were to count, I have this entire face here. So this is 1 face. Then I have 2 faces, 3 faces, and 4 faces. So that's 4 faces that I can see. Then you can look at the dotted lines. So, and that includes, I have 1 face, another face, and then we have that last face. So I have another set of 4 faces. So I have 8 faces total. There are 8 triangles. So because there's 8, we talk about an 8-sided figure, this is actually going to be called an octahedron. So kind of like polyhedron, which is many, in this particular case we actually have a number, so it's going to be octa. So our next one, is it a polyhedron or not? This one is not a polyhedron because it is circular. There are no sharp edges, there are no faces, so this is not a polyhedron. So let's go on to the next page where we have a couple more extra examples. Our next page for 3, 4, 5, and 6, we want to describe the cross-section formed by the intersection of a plane and a solid. So like number 3, this is where if I took something and I slid something into that figure, what does that underlining shape look like? For example, number 3, we are going to notice that we have a square. Even though it's a little slanted, you might think a parallelogram, this is actually a square if you were to turn your view at the top of the pyramid. So this is a square cross-section. Okay, and so our next example, now we have something cutting across the top of our pyramid. And so even though it looks a little off, this is the cross-section that we see, and it is actually a triangle. So this cross-section here creates a triangle. Even though it looks slightly off, again, if you turn your view probably like 180 degrees where this point would be facing, you can see the triangle. This is the part of geometry where it gets a little difficult because you have to visually turn 3D figures into your mind instead of physically doing this yourself. So number 5, we have another one, and so this one we took a little piece and we cut a corner, and we actually create a shape that looks very much like this, and you guessed it, it is a trapezoid. Okay, this is another way of how a trapezoid looks. It doesn't always have to be perfect like how we always see a trapezoid. And then number 6, we have this shaded cross section. And we're not sure how many sides this is, but we can always count the vertices. So I have 1, 2, 3, 4, 5, 6, 7. So remember, a 7-sided or 7-sided polygon is called a heptagon. That is a heptagon cross section. Okay, so now we're down to our last 2 examples. So 7 and 8 says sketch the solid produced by rotating the figure around the given axis. Then identify and describe the solid. So this is my pen, and I took my sticky note and I'm going to wrap it across the entire thing of the axis. So if I have one side, I'm going to do the same thing for the other side. So 2 centimeters. I still have that as 8 centimeters, and then I have 4 centimeters on the other side if I want to continue drawing it. So if we want to show that this rotated all the way around, so we show that these two are circular. So that means our total rotation is actually 4 centimeters. And we still have the base here as 8 centimeters. And then this doubled to now 8 centimeters, so 4 and 4. So this is how we would draw it. And this then describe the solid. So in this case, this is the bottom of a cone. Okay, so bottom of a cone. So number 8, we'll do the same thing, but we're going to rotate it across the y-axis, so to speak. So in this case, we don't know what this measurement is, but we know this is long enough. This extends to the other side to also be 8 centimeters, and then the 2 centimeters still stays. So if I want to redraw this, if it rotated completely, this is what it would look like if I rotated all the way. And so I have here the middle, it still stayed 4 centimeters. And then our base actually extended all the way to 16 centimeters because you have 8 and 8. And our edges still stayed at 2 centimeters on the side. So the only thing that doubled was the bottom. So to describe this would be a cone on a cylinder. Okay, and so that is our final example. Please feel free to find me on Remind as well as YouTube, Mariah Martin with the Summit High School JAG logo. This will also be uploaded to Canvas. If you have any questions, please feel free to email me at mariahmartin@misdmail.net. .org. I have tutoring hours every morning at 6:45 a.m. as well as after school on Wednesday and Thursdays from 3 to 4. Thank you so much for watching my video, and you have a great day.